Networks allow computer systems to communicate and coordinate their activity. A distributed system performs operations by moving data between nodes in the network. A sending node provides data to the communication system along with the address of where it's supposed to go. A communication system transforms the data into a form suitable for the network. It manages the process of sending the data across one or more links. Receiving node accepts the data from the communication system. As we saw in Chapter 1, computer networks are used in all types of computer systems. Many different types of networks have been developed for various use cases, but some basic principles underlie most networks. A local area network covers a relatively small area. A wide area network may cover the entire planet. The physical layer of a network provides the medium that you use to transmit data. Data rates, acceptable error rates, and wire-to-wireless all affect how ones and zeros should be represented. A computer system uses a network adapter to connect to the network. The adapter appears as an I/O device. It has a physical address that identifies itself to the network. Ethernet is a prime example of a wired network. Several versions of Ethernet have been developed. Some of them operate at speeds of over a gigabit per second. Versions of Ethernet are also used in automobiles and real-time applications. Many types of wireless networks are available, such as cellular networks. LoRaWAN was developed for long-range communication with low-power devices. Wi-Fi is a family of wireless networking standards. Bluetooth and Bluetooth Low Energy provide local links. A data link directly connects two computers. The link manages the operation of a physical layer between two nodes. Most links transmit data using frames. The frames include a header, the destination address, data payload, and error correction data. A frame can support some maximum amount of data. If the sender wants to send more data, it must be split between several frames. Logical Link Control, or LLC, multiplexes several possible transmitters onto the link. Medium Access Control, or MAC, abstracts some of the physical layer to simplify the operation of the logical link in higher layers. Links apply error correction codes to protect data during transmission. Algorithms can detect certain types of errors, typically bounded by the numbers of errors in a unit of data. They can also use redundancy to allow some errors to be corrected. The network layer manages data transmission across multiple links. The Internet Protocol Suite, or IP, allows computer networks to inter-network with each other. The Internet Protocol transmits data as datagrams. Each datagram is self-contained, simplifying restarts during failures. The Internet Protocol also provides mechanisms for managing addresses. An IP address is written as a dot-connected series of 4 numbers, each in the range 0 to 255. For example, an IP address may be 192.168.22.5. Frames are routed across links from their source to their destination. The physical, data link, and network layers are part of the Open Systems Interconnection, or OSI model. This model describes a wide range of communication networks, and it's a very useful tool for talking about networks. The physical, link, and network layers form the bottom of the OSI stack. They manage transmission and management of data. The upper layers are closest to the user. The session layer manages and administers a set of data exchanges to form a coherent group. The presentation layer deals with issues such as character codes and encryption. The application layer describes host-level protocols that can be used to build services based on one or more processes. A distributed computing system performs computation over a set of computers or nodes in the network. A client-server system provides services from a server to a number of client machines. For example, a smart home may stream entertainment either from a home media server or from an off-site streaming service. The home can also make use of a home security service. A peer-to-peer system performs applications through the coordination of A peer-to-peer service performs applications by coordinating several nodes. For example, the thermostat may talk directly to the heater in the home. Devices can communicate by trading messages. For example, a message may be a simple command such as go or stop. It may also be a name-value pair such as volume 5. A message is not an instruction in a computer. The message isn't executed, at least directly, by its recipient. The recipient sees it as data. The recipient has to first read the message to see what it says, then interpret the message to understand what it means, and then act on the message to do what the message requests. MQTT stands for Message Queuing Telemetry Transport. It's a widely used protocol to manage communications in Internet of Things or IoT networks. MQTT uses a publish-subscribe model for communication. The nodes in the application agree on a certain topics for messages. They connect to an MQTT broker, which manages the communication between the IoT devices. For example, C1 acts as a broker, while C2, C3, and C4 all connect to it for services. C3 subscribes to a topic, while C4 doesn't subscribe to that same topic. C2 then publishes a message on that topic. C3 receives the message because it subscribed. C4 doesn't receive the message because it didn't subscribe. Security is important in all types of computer systems. It's particularly important for networks and distributed systems because the nodes in the network can be used to attack each other. Here's an example of a distributed denial of service attack. The attacker generates nuisance traffic directed at the target that will inhibit the target from doing its useful work. The attacker may use hundreds, thousands, or millions of nodes to swamp the target with messages. The attacker doesn't need to own all of these attack nodes. Third-party nodes can be conscripted using malware or other methods. Another type of attack is known as man-in-the-middle. Alice and Bob want to communicate directly. If the attacker Cornelia can insert themselves into the communication path, they may be able to intercept messages and provide their own responses. The attacker could simply eavesdrop and pass on the message after analyzing them. The attacker could also substitute new messages or drop messages. We can take several steps to protect communication in distributed systems. Messages can be encrypted so they can be read only by nodes that have the right key. A digest of the message can be computed using a hash function. Cryptography can be used to generate a digital signature that can be used to authenticate the message. Thanks for watching.